The next video is about the queue using linked list. So we have seen already the stack, which is the implementation with using array and the linked list and queue using array. In this video we are just going to see queue using linked list. So as such, we know queue in the sense first in first out. So the queue elements are represented in terms of linked list. Linked list in the sense it has two elements. One is the node value and the next pointer. So here we are having two kinds of pointer. One is front and another one is rear. The front pointer is pointing to the starting element and the rear pointer is pointing to the last element. So the node structure is data with the next. Initially the data is what we have created the node and the next is the null pointer. In case of queue, we are having front and rear pointer. Initially those two things are null pointer only. So how we are going to do the enqueue operation, which is insertion of element into the queue. So when we are creating or inserting a new element, we need to create a new node and allocate memory for that. Both front and rear is null only. We need to make both front and rear points to the new node, because while we are inserting an element at first node to the queue means we need to make those two pointer points to the first element only. So the rear and the front is needs to be points to the new node which is created. So rear turns to next is also the new node, front which is also new node. So this is the enqueue operation. So front is null, rear is null. Insertion of 10 in the sense both the 10 is the new node with the next node null pointer. Next pointer is null. The front and rear is pointing to this. If you are inserting 20 in the sense the front is pointing to the first element because 10 is the first element in the queue, 20 is the next element. The rear needs to point to the next element. And inserting 30 in the sense the rear needs to point to the 30. So this is the view of enqueue operations. So what are the elements inserted into the queue? The last element which is inserted that needs to be pointed by the rear. The first element inserted inside the queue needs to be pointed by the front. So this is the code of that enqueue operation. So while we are doing enqueue, we need to create a new node with the data passed. If it is empty in the sense, make front and rear as the new node. If it is not empty, the node is already, the queue is with some elements means that rear tends to next point to the new node and the rear now the new node. Rear tends to next point to the new node in the sense the rear is pointing to the new node. And rear tends to next in the sense that rear is also the kind of linked list, so that next element is pointing to the element which is inserted, and that rear is now become the new node because while we are inserting another one element, that rear we need to access as the element which is inserted recently. That's why we are making this assignment. DQ in the sense we are deleting the element, the first element is deleted, so the front pointer needs to be updated. If it is an empty queue, we can't DQ the element. Otherwise the front needs to point to the next element and the front pointer becomes null. Okay, so that is, if the front pointer is null means we need to make the rear pointer is also null. Then we need to release the memory of the front nodes. This is the visual representation of the delete. So 10, 20, 30 is present in the queue. We are deleting 10 in the sense we need to make that front tends to next to the next which is already presented, next of that first element, and delete this 10. So we need to verify is empty. If it is yes, empty in the sense the queue is under flow. If it is not empty, a temporary pointer which is pointing to the front, because we need to delete that memory, that's why we are making that front is pointed by the temporary, then front is point to the next. So this is the front one, this front now becomes the front tends to next. Already we are having this 10 in the temporary, So the temporary needs to be deleted. Before going for the temporary deletion, if the front is null pointer, for example, if 10 is the only element present in the queue, in the sense if that is the null pointer, another element is not there, means there is only one element in the queue, we need to make the rear is also the null pointer, because we don't have an element at all. So the rear is also the null pointer because no element inside the queue. So, and finally we are deleting this temp, that is a temporary pointer which is holding the front pointer. And when we are doing the display, if the front is null and the rear is also null, the queue is empty. If it is not null, we are making the temp, because as we have seen, the queue is the size of from front to rear. So the from front pointer to the rear pointer, we are having the elements. So we need to make that front is temporary pointed by the temporary variable, that does not become null. We need to iterate and display the data. So in this case, 20 and 30 is inserted after the 10 is over. Then is empty in the sense front is null, which is null means it will return the true. Get front in the sense if it is true, the empty is true means the queue is empty. Otherwise, the front data is returned. Get rear in the sense the rear data is displayed or returned from the queue, and if it is empty, the queue is empty. So after all those operations implementations like enqueue, dqueue, display, is empty, rear, get front, get rear, we are just including the main pointer, main code. So 10 and 20 is inserted. After that, those two elements are deleted using dq. Then 30, 40, 50 in this cout, get front in the sense 20, 20, and get rear in the sense 20. While you are doing the dq, 30 is deleted. So remaining get front is 40 and get rear is 50 is the result of the code. So this is the way we are implementing the queue using the linked list. So we need to make the pointer adjustment in the next in the link list. Then only we are making that front is the first part of the queue and the rear is the second part of the queue. While we are inserting, we need to make the rear adjustment. While we are deleting, we need to make the front adjustment. If it is empty, means both front and rear are null. And if front is null means no other element is pointed by the rear, means we need to make the rear is also the null pointer. So is get front and get rear is used to display what is the first element and what is the last element, and from that we can also derive the size of the queue. Size of the queue in the sense number of elements from the front and the number of elements to the queue, to the rear. So the front is for the dq operations and the rear is for the nq operations. In the next video we will see the applications of the queue. Thank you.